Hello viewers, welcome to another interesting topic of digital communication. In this segment, we are going to discuss something more about pulse-coded modulation. This lecture is conducted by Ganon powered by Wishback. So, what we have discussed in our earlier lecture of pulse code modulation, let us have a recap. A signal is pulse code modulation to convert its analog information into binary sequence, that is, ones and zeros. The output of a PCM will reassemble into a binary sequence. So what we have discussed in the transmitter section? The transmitter section of a pulse-coded modulation consists of sampling, quantizing and encoding, which are performed in the analog to the digital converter section. The low-pass filter prior to the sampling prevent aliasing of the message signal. Let us discuss the regenerative repeater in the medium. The regenerative pulse compared with the original pulse and the received pulse will be as shown in the figure. For a better reproduction of the signal, a circuit called as regenerative repeater is employed in the path before the receiver, that means in the medium. This helps in restoring the signals from the losses occurred. Let us discuss the blocks of the regenerative repeater. This consists of an equalizer with an amplifier, a timing circuit and a decision-making device. The equalizer, let us discuss the function of the blocks one by one. First is the equalizer. The channel produces amplitude and the phase distortion to the signals. This is due to the transmission characteristics of the channel. The equalizer circuit compensates these losses by shaping the received pulses. Then the next block is timing circuit. To obtain a quality output, the sampling of the pulses should be done where the signal to the noise ratio, that means SNR, is maximum. To achieve this perfect sampling, a perfect or a periodic pulse train has to be derived from the received pulses, which is done by this timing circuit. Hence, the timing circuit allots the timing interval for sampling at high signal to noise ratio or SNR through the received pulses. The last block is decision device. The timing circuit determines the sampling times. The decision device is enabled at these sampling times. The decision device decides its output based on whether the amplitude of the quantized pulse and the noise exceed a predetermined value or not. Next, we are going to discuss the quantization. In the figure, at the time t equal to 1, the amplitude 7 and hence the corresponding digital bit is 111 as discussed in my earlier lecture. And at the time capital T equal to 2, the amplitude is 6, hence the corresponding digital signal is 110 and so on and so forth. There are two types of the quantization. One is uniform quantization, another is non-uniform quantization. The type of the quantization in which quantization levels are uniformly spaced in is termed as uniform quantization. The type of the quantization in which the quantization level are unequal, that means not same, and mostly the relation between them are logarithmic, is known as non-uniform quantization. There are two types of the uniform quantization. They are mid-rise and mid-trade type. The mid-rise type is so called because the origin lies in the middle of the raising part of the staircase-like graph. The quantization level in this type are even in number. The mid-trade type is so called because the origin lies in the middle of a trade of the staircase-like graph. The quantization level in this type are odd in number. Both the mid-rise and the mid-trade type of the uniform quantizer are symmetric about the origin. If the quantization signal is not able to follow the original message signal, an error will be generated as shown in the figure. It is known as quantization noise. It is a type of the quantization error which usually occurs in analog audio signal while quantizing it to digital format. For example, in music, the signals keep changing continuously, where a regularity is not found in errors. Such error create a wideband noise called as quantization noise. Now let us discuss non-uniform quantization. Non-uniform quantization can be handled by compending. There are two different laws in non-uniform quantization. One is mu law, another is A law. A law compending technique. Let us discuss the A law compending technique. In A law, uniform quantization is achieved at capital A is equal to 1, where the characteristic curve is linear and no compression is done. A law has mid-rise at the origin, hence it contains a non-zero value. A law compending is used for PCM telephone system. Now let us discuss mu law. Uniform quantization is achieved at mu equal to 0, where the characteristic curve is linear and no compression is done. Mu law has mid-rate at the origin, hence it contains a zero value. Mu law compending is used for speech and in music signals. Mu law is used in North America and in Japan. Now let us discuss the decoder. Decoder circuit decodes the pulse waveform to reproduce the original signal. This circuit acts as the demodulator. Now let us discuss reconstruction filter. After the digital to analog conversion is done by the regenerative circuit and the decoder, a low-pass filter is introduced, called as the reconstruction filter to get back our original message signal. Hence, the pulse-coded modulation circuit digitizes the given analog signal, codes it and samples it and transmits it in analog form. This whole process is repeated in a reverse pattern to obtain the original signal. Now let us discuss the benefit or the advantages of PCM. It is robust against noise and interference. It is uniform transmission quality. It is efficient SNR and the bandwidth is trade-off. It provides secure data transmission. It offers efficient regeneration. It is easy to add or drop channels. Then what is the drawback of the PCM? The drawback of the PCM is overload appears when the modulating signal changes between the sampling by an amount greater than the size of the step. I think we have discussed this topic earlier. Large bandwidth is required for transmission. Noise and crosstalk leaves low but rises attenuation. An IDN, that means integrated digital network, can only be realized by gradual extension of noise. The difference between original analog signal and translated digital signal is called quantization error. Now let us discuss pulse-coded modulation application. The pulse-coded modulation is used in the satellite transmission system. The next application is it is used in space communication. Also, pulse-coded modulation used in telephony. The compact disc CD is a recent application of pulse-coded modulation or PCM. Let us have a recap what we have discussed today. We have discussed today regenerative repeater, then we discussed uniform quantizer, non-uniform quantizer, then we discussed PCM receiver, PCM advantage, PCM disadvantage, PCM applications. That's all for this segment. Stay safe, stay healthy, bye.